Hello guys, this is Kamruzzman. I'm a GIS specialist working in Bangladesh, and this is my second tutorial on unsupervised classification and image identification. This is part of the image GED program in University of Jahangirnagar. So I'm going to show you the course outline, and practical session will be taken. In the image GED program, you can see there is a course called remote sensing, and the syllabus is been given, and these are the theoretical and some of the practical. In my previous tutorial, image properties and subset already been actually covered, and in this tutorial I will be explaining how to do the unsupervised classification and feature identification. These are the first basics. Actually, if you want to establish yourself as a remote sensing specialist, you have to go through this type of expertise or this type of things in the very beginning. So you have to learn it very precisely before you go into the next step. So in this process, let us explain and two things separately. So if I divide the whole process into the unsupervised classification and image classification into two different stages, and I am going to explain the unsupervised classification in the first place. So to do this, I will have to start with the Erdas Imagine. 2014 is an excellent software for the remote sensing. So, if we open a raster layer and we can see there are 4 different of images been actually in my computer. This is the Landsat TM 2010 image. I am going to do the unsupervised classification with this image. So I am adding this one into the software, and if we actually see the whole image, you can see this is not the true color has been represented in the remote sensing perspective. This is the, like if we reverse this one like 3 to 1, it will show the more like true pattern. I mean, what you see in the real world, vegetations are green, rivers are blue. So this is the real pattern we actually see. So if we want to see this in reverse way, we can actually change the layer 4. If we actually precisely do want to see the vegetation in this way. So whatever this is, let's go into the business, like unsupervised classification. To do this, we will have to go to the raster tab, and we will find the unsupervised image, the unsupervised classification tab, and this is the input. You will see the input raster image, and this is the one which is in the table of content. Excuse me. And in the output tab, there is a name required for this file, and we'll have to enter a name for this one. And this is the number of classes being identified. This is the 36 number of classes, and we'll edit as 60 number of classes. And there's another option you see, there's the color scheme option. You can see this is the gray cycle color, that will be better for us. And maximum iteration, it is the 20 number of iteration that will be good for us. In this iteration, every feature actually does 20 times correction around these points. So this is very important. The higher the number is, the more accurate the image feature is. So if we actually do all the things and give it a name, if we give it an unsupervised classification name and classify 0 as this as another category, so everything is set to be done. It will start doing the processing. So I have clicked on OK now, and all the steps are actually explained in here. Step 1, open the raster image, do the unsupervised classification with at least 60 number of class. Step 1 is if we actually do compare these two, so this is the unsupervised classification tab. There is a 60 number of class. You can see this is the 60 number of class. Color scheme as gray cycle. If we actually open it again, so if we actually keep these two by one after another side, we'll see everything should be done in this way. So 60 number of class will achieve more number of subtle difference will be identified. Color scheme as gray cycle. In gray cycle color, you can identify some other features. In color classification, it is more difficult to identify, and maximum number of iteration is 20. The default number is 10. If number is 20, it will actually correct 2 more times than the default one. So after all this set, we will click on OK, and we will start processing the image. You can see this is it may take some time according to your computer processor. Now you can see I have prepared this unsupervised 60 class line class lens set classification into 60 class, and this image has been already included in this browser. So if we actually separate these two images in two different view, that is also possible in these two views, displaying two views. The benefit of it, you can actually compare this among these two images. So if you establish a link in between, so if you move this image, you can see that right side image is already changed as well. So this link will help to establish some feature. Let us look at the attribute table. This is the unsupervised classification, and let us look at the attribute table. We can see there are like 60 class, total 60 class is there, and this has been actually divided according to their wavelength and color combination, and histogram has been shown how many pixels are actually situating in this particular class, and our target will be to actually actually redefine this pixel into an actual feature type. So this is the unsupervised classification type, and how we can do this type of stuffs. And let us let us revise this out content as well. So open the raster layer, do the unsupervised classification with at least 60 number of class, color scheme as gray cycle, and maximum iteration is 20. Third step is save the unsupervised classification as desired image, and save the unsupervised classification for submission. So you will have to actually stop here. If we actually assign with a unsupervised classification in number of 30, 40, 60 number of class, whichever is actually mentioned in the questions, and save this unsupervised classification class number into another separate folder for submission. So that's all for unsupervised classification class. Thank you everyone.